Hello everyone, welcome to Mastering Engineering Statics. In this course, we will learn the static course that is important for many students that are studying engineering departments such as civil engineering, mechanical engineering, biomedical engineering. Sometimes might learn this course also architecture engineering and other majors. First of all, today we will start with the first lesson, Introduction to Statics. So, we will understand why static is important, what is statics in general, applications related to statics, and etc. Okay, first of all, statics is related to mechanics. We have different types of mechanics for rigid bodies, for fluid bodies, hydromechanics, for example, fluid mechanics, and other courses related to mechanics. But for statics, it's related to rigid mechanics, engineering mechanics in rigid bodies. When it comes to mechanics and rigid, we have two types. One is statics and the other one is dynamics. In this course, we will learn statics. What is statics? So as we know here, statics is related to rigid bodies and is related to mechanics. That's why in some universities it's called engineering mechanics, and some universities it's called statics. First of all, what is statics? The branch of mechanics, as written here, the definition, the branch of mechanics that deals with forces acting. Okay, dealing with forces. This is first thing, acting on what? On rigid bodies. Okay, so we know that statics is related to rigid bodies. Okay, as you see here from these two figures, we have rigid body here and rigid body here. Okay, after that we have at rest or in equilibrium. So, at rest, for example, the figure on the left, this body, this box here is at rest, not moving in any direction. Or in equilibrium, as we see here, there is this body, this box, and there's a person pushing this box. Okay, this is in equilibrium. But what does it mean? Meaning they are not accelerating. When there is acceleration, it's dynamics. It's not statics anymore. When there is no acceleration, it's statics. But that means also the body is moving, but in a constant velocity. So it's statics. When there's no constant velocity, there's acceleration, then it's dynamics, not statics anymore. So as we see here, the difference, this body is only standing at a rest condition. This body is standing, but someone is pushing this body also as well, but with a constant velocity. Okay, then we will what we will do in this course is concerning, or what we will do in statics is concerning the determination of external and internal forces acting on a body. So we will determine the external and internal forces acting on a body. So we have internal forces and we have external forces acting on a body. For example, here on the left figure, we have the gravity, the weight of the body itself in the gravity direction. Also, we have the support here, the pushing the body itself, and etc. While here we have also the weight of the body itself going downward, the gravity as a support or the surface it's standing on. Also, this person is pushing the body, and so on. This is the concept of the external and internal forces. We will explain it deeply during the lessons and in the following figures. First of all, you will see the force vector. So, for example, you will see examples like this. We have forces in the positive y, negative x direction, negative x, negative y direction, and all these forces are inclined not on the x-axis or the y-axis, and you might see forces on the x-axis and y-axis. Why it's important to learn this point, force vector, is to know how to define the inclined forces on x-axis and on y-axis, because it's common in structures to have inclined forces, and it's common in beams and frames when you have examples in this course to face forces like this, inclined, not exactly on the x-axis and on the y-axis. When we have a force on the y-axis, for example, like this one, on the y-axis, in that case, this force, let's consider it as F3, for example. F3 is equals 15. It will be on the y-axis easily. Nothing will happen to this force. It's constant on the y-axis, going upward, and equals 15. But for example, the 5 here, it will be rotating to x-axis, and it will be equals to a specific value, and on the y-axis, and equals a specific value. That's the difference between the force acting exactly on x or y-axis, or an inclined force that is between x and y-axis. Yes. Second thing is the beams and frames. On the left side, you will see the beams here. It's very important, and it's very one of the main topics in this course is the beams. How to analyze the beams, how to know the forces acting on the beams, what is each force acting on the beam, what is the support forces, and so on. So very quickly, this example has a moment here on the left side. On the right side, it's very important to know what's the difference between the moment and the normal force. Here it's a normal force or a concentrated force or load, and here is a distributed load. There's also a difference between the distributed and the concentrated load. And here it's the beam section. We have two supports here carrying this beam. It's important to learn all these. All these mentioned before are external forces. For example, in the definition we mentioned that there are also internal forces. For example, some questions might ask the students to find the internal loads inside the x point or in the x point. So in that case, it's internal. So it's very important to know how to find the external and the internal, and what's the difference between them. This is all about the beams. Okay, about the frames or frame sections. Frame sections is like the beam, but is closer to the reality than the beams, because here we have beam and two columns. So it's explaining how the structures are. It's about beams and columns. So what's the difference? How to calculate the supports in the case we have beams and columns. Also we have concentrated, distributed load, moment load, or a moment here. So what's the difference between these? How to analyze this frame? Yes. Okay. The third point is the trusses. It's very important to know what is the truss structure and what's the difference between the normal structure and the trusses, and where to see the trusses. The trusses are in general common in the bridges and in the communication towers. We have this example. It's to visualize and to see how the trusses looks like. So we have steel bars everywhere. The trusses are made of steel, as you see here. Also we have supports, we have external loads. So it's important to know how to analyze the truss and how to know the force at each member of the truss. After that, how to find the location of the centroid. So for example, we have this member section, and it looks like eye, but it's not exactly an eye. So how to find the middle point of this section while it's not symmetric. And after determining the location of the centroid, then we can find determine the moment of inertia and other applications. This is part of the examples you will see in this course, and there are also more examples and other topics to talk about in this course. This is only the beginning, and it's just a preface for what you will see and what you will learn in this course. This course is very important also for students, especially in civil engineering, because it's just the start for strength of materials, structural analysis 1 and 2. Also, reinforced concrete is important to learn this course in order to learn the reinforced concrete design. So it's a main course, and is very important for the first 2 years. students. Thanks a lot. I hope you've learned a lot from this lesson, and hope to see you in the following lessons as well. If you have any questions, text me directly, and see you in the next lesson. That's everything for today. Thanks a lot, and have a great day.